Morning, good afternoon, good evening. I'm Jayshree Hegde, welcoming you all to our webinar Enhancing Data Quality in MQTT-Based IoT Data Pipelines, where our experts today will discuss how schema validation and policy enforcement capabilities within an MQTT broker can ensure data quality and integrity. It is a pleasure to have you all today. Now, allow me to introduce you all to our speakers for today. Stefan Frehse, Engineering Manager at HiveMQ, Michal, Product Manager at HiveMQ, and Michael Parisi, Product Marketing Manager at HiveMQ. Welcome, Stefan, Michal, and Michael. Thank you for taking time today to help us understand why data quality matters and how to enhance data quality. Before we kick off this session, I would like to share a couple of housekeeping pointers as usual. We are recording this session and we will share the recording as well as the slide presentation in a follow-up email. We have a dedicated Q&A session. However, feel free to add in your questions during the session in the Q&A box so we could answer them later. Lastly, I will launch a short poll during Q&A. I request you all to participate. Now, without further ado, I will hand it over to Michael. Welcome, everyone.
Thank you, Jayshree. Hello, everyone. Welcome. I just wanted to, before we get started, I just wanted to introduce myself really quickly. My name is Mike Parisi, and I'm a product marketing manager at HiveMQ, where I primarily focus on all features related to our MQTT broker. I'm going to kick this thing off, and then my colleague Michal from the product team is going to provide a couple in-depth use cases for your enjoyment, and then my colleague Stefan is going to close things out with a high-quality demo, and then we'll save a few minutes for the Q&A, as Jayshree had mentioned. So just real quickly to give you, a feel for the agenda, we're going to be talking about the importance of data quality. We'll be talking about MQTT and data quality, data validation via data schemas and data policies, and how you can maximize the overall business value of your IoT data. Then, as mentioned, we'll have some use cases, a demo, and then a bit of a Q&A. So without further ado, let's get started. So as far as the importance of data quality, as previously mentioned, we're going to be talking about best practices for enhancing data quality in an MQTT-based data pipeline. So first off, when we say data quality, we're talking about accuracy, we're talking about reliability, and we're talking about consistency of the data collected from IoT devices and sensors. IoT systems, as you all know, generate extremely large amounts of data from various sources. And, the quality of this data is crucial for making informed decisions, optimizing operations, and just achieving specific business outcomes. And segging into data pipelines, they're made up of a series of processes and tools that are used to collect, transform, and move data from one or more sources to a destination where then it can be stored, analyzed, and then utilized for business purposes. They're an essential component of data engineering and data management in organizations that deal with extremely large volumes of data. They're just help to ensure that data is processed efficiently, reliably, and consistently. So MQTT and data quality. So when you're planning your MQTT use case, why is enhancing your data quality a vital aspect that you must take into account? Besides the obvious, think about this. Numerous data producers publish MQTT messages on an MQTT topic. On the consumer side of things, multiple services can process that data and then build desired application logic around it, which is known as a data pipeline. In IoT use cases, the number of producers and consumers can be extremely large. We're talking millions of consumers and producers. That's just pretty typical. And as you all come to know, managing an enormous number of clients can be very challenging as devices, they embed MQTT clients. They're, continuously being updated, for bug fixes or adding new features. In many circumstances, there's third-party vendors that update their devices and they're not coordinating with the data consumers, and as this can lead to unwanted or costly downtimes, of application logic. So the idea is to enforce necessary behaviors to keep producers and consumers decoupled. So right now I want to talk a little bit about data validation, specifically via data schemas and data policies. Data validation by virtue of schemas and data policies lets you ensure data quality and integrity in an IoT use case. So, at this point, it's kind of important to note MQTT is data agnostic. The broker can move your data from A to B, securely, reliably at scale, but the protocol doesn't understand or place value on it, and therefore MQTT clients do not typically validate their data. Additional frameworks are required to check consumed or published data. In most cases, low-powered devices don't necessarily have the resources to validate a schema. So the best way we can get tough on bad data in enterprise environments is with a centralized MQTT broker. This is where HiveMQ Data Hub comes in. It features an integrated policy engine in the HiveMQ broker that can validate, enforce, and manipulate data in motion to ensure data integrity and quality. So kind of getting back to the concept of schemas and policies, with data schemas, you're able to create that blueprint for how data is formatted and the relationship it has with other systems. This can be these can be very well known data schemas such as JSON or protobuf. And then on the policy side of things, data policies define how the actual data pipeline is handled in the broker, in particular, the schema validation. So think about it this way: an MQT message can be considered valid or invalid on whether it conforms to the provided schemas. If an MQT message conforms to any of the schemas, it's valid. Otherwise, it's invalid. Pretty simple. Depending on this determination, actions can be taken as well, such as passing the message to the consumers. It can be dropped or rerouting it to another, MQTT topic or, any other data flow function. These scenarios are instrumental in maintaining decoupled data pipelines between producers and consumers, as I mentioned earlier. And so just to kind of tie it all together in, a neat little bow, we can define a data policy in three basic concepts. So there's matching. A policy should match for specific criteria, like a topic filter. Validations, a set of validations is executed for each of those matching incoming MQTT messages. And then actions. Validation steps have outcomes which further actions need to be taken, like you could log a message, increment a metric, or even reroute the MQT message if the data is invalid. And just to take things a little bit further, beyond data validation, there are a couple more key features Data Hub has to offer that I'd like to mention because they're really key components to enhancing your overall data quality, which is kind of the theme of all of this. So Data Hub also offers behavior policies, and these allow you to uncover bad acting clients directly in the broker. They dictate agreed upon behaviors for how devices should work with the broker by logging, stopping, or even transforming those behaviors. So there's a flow control functionality that enables validation of in-flight message flow patterns to avoid inefficiency, like constant repeating connect, publish, disconnect. And you can even enforce ingestion limits to restrict how much data clients can actually ingest, like no oversending of messages, even if that data is correct. The idea here is these policies significant limits performance issues as they empower you to uncover clients that are violating, good resource usage, and they provide the ability to detect and drop repetitive messages. And then coming soon, data transformation with the MQT or with the HiveMQ Data Hub, you'll be able to, move more operations to the edge so data can actually be standardized. Like simplest terms, like automatically converting Fahrenheit to Celsius, or even converting to the metric system. You'll be able to, filter out undesirable data, temperatures less than, say 20 degrees. And, data from various sources and versions can be unified into a singular data standard, all before it reaches the consumers. This significantly increases efficiency as processes are automated, and it replaces that, manual transformation logic with clients, which can be time consuming, often error prone, and, realistically, it's just not very scalable. So to tie things together, I want to talk about how the HiveMQ Data Hub helps you really maximize the business value of your data. But before I kind of jump right into that, I just wanted to do kind of a brief rundown of how the Data Hub actually works. Basically the Data Hub, what it's doing is providing data services to customers, and it becomes an independent arbiter that facilitates the standards enforcement for clients' behavior and on the data that they publish. So with Data Hub, users can specify how the broker should behave and control their IoT data by introducing policies. These policies, written by developers, DevOps engineers, engineering managers, etc., for data producers and consumers. Then they're then made available to the Data Hub via the REST API in the broker. The policy engine then implements and enforces the expectations provided by these policies in real time, and then the data is sent, to the consumer in the format that they expect. So just to close things out, when we say maximizing the business value of the data being transported, we're talking about defining policies, transformations, and validation requirements to ensure that data running through your platform is accurate and meets the standards that your organization requires. And this kind of boils down to just 4 basic things. We're providing more accurate business insights on validated data. This way, you're not acting on rogue data and which generates really just more noise than insights for the company. We're able to streamline data definitions across your business and offer a single source of data truths that businesses can rely on. You're adding context and quality control to your data, and you're cutting down on that time spent identifying and fixing data errors. Making more accurate and better business decisions because you have access to all that high quality, up to date data. As far as operational efficiency, you can drastically cut down on that operational maintenance and development costs by mitigating bad data, reducing waste, streamline projects, and resolve pipeline issues earlier and at a much higher frequency. And then you're decreasing that downtime by validating repeating patterns or bad data flow, or by defining expected behaviors. So this all kind of boils down to keeping costs down. Streamline data processes, ensure they're well defined and standardized. You can validate and manipulate that data before it reaches your integrations, databases, or external systems. And then behavioral policies really help to prevent those bad actors from bringing down infrastructures or services due to sending oversending or rapid connections that could eventually result in downtimes, financial losses, none of that good stuff. So I'm going to stop there, and at this point I'm going to transition things over to my colleague Michal, who's going to give you a little bit more context to this by demonstrating a couple of use cases. So on that, I will send things over to Michal.
Thanks, Mike. So I will try to build up a little bit upon what Mike presented already, and talk about 2 particular use cases that we are trying to tackle, or 2 problems that we are trying to solve. So the first one is stopping bad data. What does it mean for us? This is simply a data that do not adhere to some agreed standards. This means bugs that make you lose time for spend maintenance. This means polluted data pipeline. So lack of good process insights and potentially bad business decisions that you will make based on this bad data. How you can identify it? Identify bad data. So simply put, this is just data that doesn't follow data schema, and it can range from just the changed structure of a message completely, single field name or type being changed, and now that does no longer make sense, or it can be in a different formats, like someone can send a message in XML instead of JSON, or the message can just not compile at all due to various bugs that can be introduced during the development process. So what we can do with this bad data using Data Hub? So that depends on the severity of the bad data situation and how crucial it is to keep the data pipeline clean. So starting from the most soft actions, let's say, we are introducing improved monitoring by automating additional logging and custom metrics related to data pipeline. You can also supplement the message with additional information in form of user properties that will be added to to the message, or in the more severe cases, you can decide to entirely drop or redirect the message if you want to entirely block the bad data from reaching the system, or if you would like to separate it. How can I leverage this? So a good example would be of very simple policy in Data Hub, but very powerful, could be a simple JSON validation. So just check if the message is a valid JSON. That is useful to identify all these cases where the message that comes is totally rubbish and do not compile, or is sent in a wrong format, like XML instead of JSON again. So with on every you could apply this to every message going through your data pipeline. So just cover everything by wildcard topic, and every message will be a subject of this kind of policy. And all valid messages, you can just, for example, increment the quality metric to keep track of the health of the data pipeline and send it further upstream to other devices, or downstream to the analytics services like you would normally do. But for the invalid messages, you can add user property that specifies the validation error. You can then redirect this message to a different topic, like invalid messages / original topic, and that will be used to store for further debugging. So you could potentially list the top clients that are sending bad messages, or top topics with the most polluted data pipeline. And this very simple policy can already give you huge benefits. And for all the HiveMQ users of our enterprise broker, this is free and already introduced with current release. Okay, the second use case is stopping bad clients. So those are clients that don't follow agreed upon behavior in such a way that it can increase the costs, hurt the performance of the system, or even compromise the integrity of it. You can identify bad clients by, there are certain behaviors we introduced, behavior models that we track. And this can be either clients that publish bad data repeatedly, or clients that do not follow some good practices of MQTT. So one such model is repeating pattern of connecting, publishing, and disconnecting, and connecting, publishing, and disconnecting, which is very much more expensive than in terms of computation than just normal behavior: connect, publish, 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 publish until you should disconnect, or not implementing report by exception. So just spamming all the time with the same value, although the metric haven't changed. Acting upon such bad clients. So again, depends on the severity of the use case. You can add enhanced logging and custom metrics for easier debugging and just understanding what's going on within your cluster. But if the use case is necessary, like if it's necessary in your use case, you can decide to drop the messages sent by those bad clients, or even disconnect such clients to stop them from this malicious behavior. So an example where it could be useful is that a sensor that pushes the temperature readout every second, although the temperature haven't changed, or it publishes the temperature outside any realistic range, so it's obviously malfunctioning. Okay, so with this introduction, I'm handing over to Stefan to show you this in action. Thanks.
Yeah. Hi, I'm Stefan. Yeah, I'm going to through a real demo with the HiveMQ Data Hub up and running, and show you some schemas and policy and how this works with Data Hub. So let's start. Before we can enhance anything, I thought, okay, we first try to measure something, to measure how many data points, or basically how much data messages are invalid or invalid, to make that at first we have visual to see what's going on. Of course, in the meantime, we identify bad data by policies and schemas. And the next step would be, okay, we want to enhance the data pipeline by dropping, for example, bad messages in your pipeline. Okay, before we start going into some details, just a quick intro again here. We have a policy engine, part of a Data Hub. We have two ways getting schemas and policies into the policy engine. It's via the REST API, very common, or if you want to make it a little bit easier, click it through our control center. So the control center gets now full support for Data Hub for creating schemas, data, and behavior policies. What we have here in our scenarios, we have data producers sending some good messages, so conforming to a certain schema, and we have some data producers sending invalid messages. It could be a very simple one, like you have a missing field in your JSON schema. For example, a timestamp is missing. For some sensors, missing a timestamp, but it's actually crucial to have the timestamp to run your business case. So we want to identify those clients, calculate a quality metric, and at the end, dropping those clients, that clients get a response code with the actual reason code to fix their problems. Yeah, let's start. Let's start with the schema. It's a simple JSON schema. We call it just machine data schema right now. It's sending some data, has an ID, a type, version, a timestamps we talked about, and also a value. We don't care so much about the value in this example, but at least we care that all these fields are required so that my data producer needs to send all those data. And let's go to the control center to create that JSON schema. We have our control center of HiveMQ, and we have a Data Hub, a new menu item here. We go to schemas and just click through our wizard here. This is basically the list of our schemas I have on my enterprise broker here. It's basically nothing yet. We will create one, then at the end it lists a schema ID, a certain version. We will come to that, type, last updated, and some other actions. Let's add a schema. Let's add a schema. We call it machine data. It's a JSON schema. And let's just paste the JSON schema I've here prepared in that file here, paste it in. It's exactly the thing we just talked about. Our machine data, all those fields are here required. By the way, some documentation is also shown here on the right-hand side. If you want to look into what actually schema definition is, there's a typical JSON schema specification. We follow those schemas specifications. So you just go there and use the same JSON schema. Okay, let's save the schema. It's there. So that's great to have that in the broker already, but nothing happened so far. The policy is now used to basically enforce the expectation. But before we go into it, just a quick list here, what it actually is. We have machine data, the actual version. You can update schema versions. Can also use different version in your data policy if you like, or just use the latest one. That's all possible with the policy. We also support protobuf. We skipped that in this demo. It's quite similar to the JSON approach here. Yeah. So we have that done. The next step is now defining policy. And the idea of defining now the data policy is, for all my clients, we define a topic filter called the wildcard. So we care about all data sending to the broker, not just particular data, subtopics, whatever. We care about everything. Then we want to validate the incoming data against the machine schema we just defined. And in both scenarios, when the data is valid according to the schema and invalid according to the schema, we want we would just want to increment a metric for both scenarios. So let's come to the actual policy we want to create. Here I showed the rather summary a bit of the data policy, how it looks like in JSON. But we care today about just the control center version of it, how to create that in the control center version. If you want to have a closer look to the JSON specification, the documentation is really detailed, explaining how this works. Also, our policy cookbook at GitHub is explaining how that works, and plenty of examples are presented there. Okay, let's go to our data policy list. Create a new policy, give it a name, machine policy, as we just showed here in our data policy definition. We want to do this for the topic filter wildcard, basically for everything. I put here this wildcard in. The next step is I want to add a JSON schema validator. So I can have multiple schemas, but in this scenario, just one. We add a schema. Actually, the schema ID I just registered there. It was named as machine data. We use it in the latest version. And that's everything I need here. Everything that this is basically the validation of my incoming data against this specific schema. But as we here presented in this requirement, we want to increment a metric for both scenarios. There's one scenario on failure, and there's one scenario for on success. So let's define an action for the on failure scenario. So basically, when the incoming data is not valid according to that schema, we want to increment a metric. We have some functions here available already. For example, this increment counter matrix increment counter. What it does is it creates a custom matrix with predefined prefix plus a customized metric name to build your own, let's say, monitoring if you like, and to see, okay, how is my data pipeline actually performing right now? And if it goes up or down certain thresholds, you can alert something, or at least you have a better understanding, you have a better observability about your data pipelines. So for the on failure action, we want to call it bad machine data. And every time a bad message comes in, we want to increment this metric by 1. And on the on success phase, it's quite similar. We want to increment also a metric, you call it good machine data. We also want to increment it by 1. That's basically everything I need to do right now. Going to the summary page lists basically what the actual policy is going to take. So basically, it shows the expectation. There's a machine schema, machine data schema mentioned with the latest version and those 2 metrics defined. Let's save that one. And let's go to send some random data. I've some real raw data here shown. We have a script that generates good data, some script that generates bad data. Let's start the good data. Let's start the bad data. Nothing special so far. So basically, I have 2 data consumers here simulated. And on the other side, I would like to consume some data. So I subscribe basically to everything, and just to show you what's going on here. Stop it for now to demonstrate what's in here. Do you see on my screen?
Yes.
Okay,
Yeah.
thank you for letting me know. So we have here data, again, bad data is generated by a simple script, and good data is also sent by a simple script to data producers. On the left-hand side, I have an MQTT client subscribing to the wildcard topic. Again, I wanted to show you those 2 data points here. On the lower part here, and the second one is ID type version timestamp in an arbitrary values there. And then the other one, I have ID timestamp version and value. Here, in this case, the timestamp is missing. So, but the timestamp is crucial based on my data policy. I defined that in my data policy. I want to know now, okay, what my data quality looks like. I go back to my control center, going to data hub dashboard that shows me basically how the data pipeline actually is performing right now. And I see, okay, I have some bad clients here listed. The last X amount of configurement number of clients are listed here. I called the bad client with the client ID bad client. And I see, okay, this bad client is sending bad data. Latest, in total, almost 40 bad messages, actually. I also see the policy that is actually validating the data and actually shows these bad data. I can go into it and see what's going on here. But that's for now everything I wanted to have. At least I wanted to see, okay, how is my actual data performing? And the metrics I used there, it's quite the same one I showed here. You can use it in some monitoring tools. We have, for example, we have the Prometheus extension tool. It's get access to that metric. You can embed this into your Grafana dashboard or whatever monitoring solution you have. So let's going back. So what we did, we get this data policy up and running. We have our data clients sending good and bad data. We measure that, and that's already a lot of things I already wanted to have. So 1/3 is bad data. I see that in my dashboard here. Roughly 1/3 is bad data and 2/3 are good data. So at least I can measure my quality of my data pipeline. So that's quite nice. The thing I wanted to have now is I want to drop actually the bad producer. So it's nice, of course, to have that, but in my use case, I really require that the timestamp is provided for my data producers, and I don't have that right now. In order to ensure that my use case is working, I need to stop that thing because it wastes my bandwidth, computation, and resources at all. So I want to drop that thing. I can do that by adding the MQTT drop function to my data policy. Going back to my data policy, machine policy, going back to my action on failure, and then another task. We distinguish in general between two general concepts here. We have terminal functions and non-terminal functions. Non-terminal functions are something like incremental mimetic. It has some side effect, creates a matrix, or logging a message, or something like this. And terminal functions really terminates either the pipeline or dropping the message, redirecting something. It's also explained here on the right-hand side. So let's drop the message. You can provide a reason string to the actual data producer to understand what's going on. What is my error, actually? There are some variables you can use that are interpolated at runtime, for example, about the validation error. For JSON, for example, explains you what is wrong according to the JSON schema. You can also use other variables here like policy ID. If you have multiple of those, you get better understanding what's going on. The topic, client ID, all the things you can use in the reason string to get it back to the client or to some other functions. Okay, let's leave it for now here. We want to drop that message. Save data policy. We're going back to our data consumer here to see whether my data consumer gets only valid messages now. What I already can see is here, all my new data points have only valid messages. They all include the data timestamp, the field timestamp. So I can ensure bad data is now excluded from my pipeline. I also see that here on my data producer, I get some negative pop-up that basically tells me, hey, the broker was declining that data point. So in order to get some more details in, I can go into the reason code and stuff like this and to look what's going on here. We skip it for now to make the demo a little bit more easier. Okay, we have that set up. That's nice. I got my data point, so my data pipeline's now cleaned up. So I measure it, I clean it up, so my downstreaming service can rely on correct data as I communicate it. So data policy is done. That's nice. The next step is to give you a little bit of idea what the behavior policy is. A data policy is about the MQTT message itself. We call it mostly MQTT payload or something. But there's actually more about that. When a client connects to a broker, it has certain behavior, and it's a certain usage with the MQTT broker. It connects, it publishes messages, it maybe publishes the message again, or unsubscribe or subscribe. There's certain behavior of client, because MQTT is a general flexible protocol, but we want to enforce certain behavior to get a reliable use case. If you're going to give an example, a temperature sensor or a device sending temperature values, sending duplicates over and over every second, but temperature usually don't change that much over a matter of seconds, right? And in order to stop that, you can drop those duplicates in for your downstreaming service to reduce costs, load, and stuff like this. And that's what we called, so where we can enforce it is behavior policy by defining a model across the complete client lifecycle. We have basically 3 main behavior models available, and with the release of Data Hub, we will continue to work on more, but I will show you one behavior policy. Let's clean this a little bit up here to show you the examples. Clear that. We have here also clear that. Again, we have a data consumer here. Oops, sorry. Going now to the data policy again. We would just want to make it a little bit easier for us in the demo with the data policy now going to the behavior policies. It's from the beginning quite similar to a data policy. You have a policy name, duplicate policy, we call that. Now I have to provide a client ID regular expression, which clients are actually interested in. And so I would like to enforce certain behavior, want to analyze or monitor the behavior. Let's do it for every client now to make it also a little bit simpler here. Let's select the behavior model. We want to catch duplicates in the scenario. Also here in the control center, a behavior model is shown, how the internal or how the actual model is defined, one transition to another transition to actually catch certain behavior. And those transitions can now be, you can add additional functions to it. I show you this in here in this example. Add another function. I define a certain state transition from a certain state to a certain state. In my example, I wanted to show you to drop duplicates. I don't care about the original state. I just say any. But I would like to know, once this behavior model is going to a duplicated state, I can just read that from the documentation. Duplicated state means at least two messages consecutively are the same, but I want to drop that. So there's a state transition from any to duplicated at an event for MQTT publishes. Anything I want to do is I want to drop that message. Again, I could provide an MQTT reason code to the actual data producer to make it clear, hey, you sent a duplicate message, I dropped the message. I can save that policy. Going back to my artificial client here, I connect using the MQTT CLI. I have my consumer up and running, connect to the broker, and now sending a message to the test topic with a test message like some test, quality of service 1. It's fine, right? That's the first message. I got it on my data consumer, I see that. But now I'm sending the same message. And it's got dropped, right? You see that there's negative pop-up. I don't see that at my data consumers, so I can avoid sending duplicate messages. That wraps up basically the first two simple examples about data policy and behavior policies. That's everything I wanted to have. Thanks. That was the demonstration of Data Hub using the Control Center for Data and Behavior Policies. Thank you. I hand over to Jeffrey.
Cool. Awesome, Stefan. That was a wonderful demo. I request all the attendees to give us a thumbs up if you guys like the presentation and the demo. And we will kick off with the Q&A. Thank you so much. We'll kick off the Q&A, and I will also launch the polls. I will keep the polls launched until the end of the session. You guys can take time and cast your votes. And thanks for doing that. Just give me a minute while I launch the polls. So the polls are up, and we will kick off with the Q&A. There are lots and lots of interesting questions coming in. We will cover them one by one. So there is a question in the Q&A section. It says, can you provide examples of how bad data has negative impact in business?
Yeah, I can cover this one.
Thank you.
So first, it's just a loss of time, waste of time. When you introduce bad data, that means something will not function properly and you are losing time for debugging. But like answer maybe more relevant for business decision makers is that once you, maybe smart manufacturing case, once you spend a lot of money to get the insights from the site by introducing various sensors that measure the value of what's going on in the factory. How is the process doing? Then if the schema is broken, then the data that you are collecting is garbage, and you just cannot get any return on that investment. Hope that answered your question.
Cool. Thank you so much, Michal. Let me move on to the next question. The one from the Q&A. So the attendee is asking, is there standards like RFC or other which describes JSON schema?
I can answer that. Yes, there is a JSON schema.org specification page. Basically, it covers different kind of specification. Yeah, language itself, it's specified in JSON that tells you, hey, those fields are required in that particular type, even value ranges you can define. Yeah, it's actually a standard heavily used in that kind of systems. So I definitely can recommend to take a look at this. It's very helpful. Plenty of libraries out there to read those schemas, validate against that. Yeah, and the broker / data hub supporting up to the latest version of schema specification.
Thank you, Stefan. Let me move on to one question from the chat section. So, Mr. Bajit is asking, either to stop bad data, is it possible to make the data sender in the idle for a while and activate it one data ready but judged good?
I can try to answer that. That's really interesting, actually. And the thing is, in many scenarios, you don't have control about the client. What we already thought about is, of course, once you have bad data or it has reached the broker, we can at least a little bit delay basically the response code or the response packet to the client. But it creates a little bit more load to the broker and some weight of resources. What you need to do is you need to touch the client implementation to handle it. But it's a very interesting thing. We already look into it. So thanks for the question. I really like it.
Well, thank you so much, Stefan. There is one question from the Q&A. The attendee is asking, action on failure metric is a topic by itself or something accessible via property API?
Hopefully I get the question right. So the action you can define in an on-failure case. There are some predefined actions you can run in a policy engine. Like I mentioned, the terminal and non-terminal functions. What we are working right now is to make it even easier for customers, like putting scripting language to it, so people can customize their own action on failure, whatever trying to correct those, or sending to whatever system to do some customization. Our predefined functions are quite solid. But of course, we are waiting for some feedback to, maybe even add more to the action pipeline. Thank you.
Awesome. Thanks, Stefan. Let's move on to the next question from the Q&A. The attendee is asking, when performing schema validation with the policies, will the data still go to all subscribers? Or can the bad or invalid data be discarded at this validation step? It seems that the bad data is still passing through to subscribers.
I can answer that as well. So yes, you can. Basically, what you can do is with the policy engine. In an on-failure case, you can say, you still want to keep that data, but you want to redirect it to a different topic so that the subscriber is not getting this bad data. But you can have on a redirect topic a subscriber to analyze and get this in quarantine to isolate basically bad traffic from good traffic, to analyze the reason and to debug it further. In other scenarios, you can just say, okay, I just don't care. I drop the message because I want to really be sure my downstream service are in a good state. So that's up to you. You can freely define that in the policy engine.
So thank you, Stefan. There is one more interesting question in the Q&A. Probably this is for you, Mika. So the attendee is asking, do you have any plans to support arrow schemas as an alternative to JSON and protobuf?
Yes, it is one of the features on our roadmap. So I am interested in that use case as well. So if you would like to talk about this one, I would be keen to have further conversation to help me form the further development of the product.
Well, thank you so much, Mika. Let me move on to one more interesting question from the Q&A. Is there any impact or change to policies if using Spark-Plug-B specification?
I can try to answer that. So, I mean, trying to understand the question a little bit, is there any impact regarding performance or any behavior or change to policy if using Spark-Plug-B? So basically, Spark-Plug-B is encoded by protobuf. So basically, you can define the protobuf schema, upload it to the data hub, and get it validated against the Spark-Plug-B specification. It's quite similar to JSON schema. But of course, getting Spark-Plug-B as a first-class citizen in a broker is something we are looking into it, actually.
Thank you so much, Stefan. Let me cover a couple of questions from the chat section. So Gary is asking, how do we ask for MQTT when buying the QMS or ERP system? And Gary has a follow-up question. What interface do you have with PLCs?
I can try to answer the second question. What interface do you have with PLCs? I don't get the first question, actually. Interfaces, yes, we have also another project, actually, another product in HiveMQ. It's called HiveMQ Edge. It's a gateway between, protocol. Basically, it offers protocol adapters, getting PLCs like Modbus, S7, all that kind of stuff transformed into an MQTT workload. So that's exactly where we built HiveMQ Edge for. And then, maybe the first question, I don't get it.
Okay, cool. There are so many other questions to cover, so let's move on. I'm covering one of the questions from the Q&A from the attendees. So the question is, can you recommend different techniques for validation of metrics and validation of commands? Are there any differences?
From the pure practical point of view about JSON validation or schema validation, I don't think that's the difference. What I can say, sometimes in metrics, you care about the actual real value instead of just, let's say, the fields. So you care maybe about the data range. So it's probably more interesting for metrics. Validation of commands, I would say you assume here commands about sending to a device to do something. Maybe you would really be sure that the command is correctly formed to not harm anything on the device side. I wouldn't say there's a technical difference in using data policies, but of course it's a difference how you formulate your schemas.
Cool. The attendee has a follow-up question. Probably this question is from the demo that you presented, Stefan. In the example JSON data, what is the meaning of version field?
Yeah, a version field is just another field in your JSON payload. From the JSON schema perspective, it's nothing special. It's just I wanted to model a certain, in my machine data, I wanted to model a certain version of a machine data. This is just an example. No special meaning of JSON.
Thanks, Stefan. There is one interesting question in the Q&A. So the attendee is asking how AI and computational intelligence and IoT platform managing MQTT protocol can play an important role in isolating bad and good data.
So I can try to take this one.
Uh-huh.
Schema validation is a very simple implementation of a complex problem. It requires some manual work. We are looking into how we could leverage maybe AI to distinguish these messages automatically, but it's not that easy. But one important thing is like if you want to fit the large AI models with data, you need a very performant broker. Definitely, this is some area that HiveMQ would like to grow into in the future.
Cool. Thank you so much, Michal. I'm trying to look for other questions that are in the Q&A. So there is one question from the attendee. What latency data validation can introduce? For example, verification of JSON format. Does this add milliseconds or more?
I can try to answer. So we run a bunch of benchmarks, of course, for JSON validation and protobuf validation. When you talk about performance and latency, the answer is mostly it depends. It depends a little bit here on the size of the JSON schema. If it's something like we saw in the demo, or maybe even larger, that's fine as well. We had a couple of milliseconds, but just milliseconds in a very low end. If you have JSON schemas with hundreds or even 500 or 1,000 fields, which is typically very unusual, then you can add up to 10% or even more latency.
Well, thank you so much, Stefan. I am actually looking for more questions that are coming in. Okay, so there is one interesting question. The attendee is asking, does the data validation work for all MQTT clients?
I can answer that. Michal, would you like? I don't care. It's so basically you don't have to touch your MQTT client. It's just for work for MQTT 3 and MQTT 5 clients. It works for both actually. Yeah. Sometimes you have devices with very old installations. You cannot touch it anymore. They're even in the field for years, and that's also the reason why we make sure still supporting that cases to support older clients with MQTT version of it, and still make sure we can cover that in the policy engine. So yeah.
Good. Thank you so much, Stefan. There is one question which is off topic. The attendee is asking, do you have uncompressed functions or compressed payload?
That's an interesting one. Probably the question is, I'm trying to reformulate maybe. If you have a payload that is compressed by some kind of compression algorithm like zip or gzip or whatever, and probably you want to unzip this in the broker to get this then validated. And it's not yet there, but it's an interesting use case. It, of course, in that scenario, creates a lot of load to the broker because you need to uncompress the data, which is typically very CPU intense, which then at the end increase the overall load of the whole cluster. Interesting use case, but it's not possible yet.
Cool. We have covered most of the questions. So I do see a couple of them in the Q&A. So I'm not sure if we have covered this question. When performing schema validation with the policies, will the data still go to all subscribers, or can the bad or invalid data be discarded at this validation step? It seems that the bad data is still passing through to subscribers.
We had that one already. So
yes, I guess so. We have already covered that. Cool. Okay, all right, cool. So I'm just looking for other questions that have been left out. So there's one open question asking, when is a policy evaluated?
the message is reaching the broker, the MQTT message, whether it depends a little bit whether it's a behavior policy or data policy. Let's consider data policy. When you send an MQTT publish message to the broker, it first gets, of course, into the MQTT protocol decoding step. So, of course, we need to understand that's an MQTT message. Then it's going into the policy engine first. It's checked whether everything is fine. Then it goes, if it's valid, and if you don't drop the message, then it goes into our extension system. You can do basically customization of your, or streaming to some other databases, whatever, if you like. And then it's going out of the broker to the subscriber. So MQTT decoding, policy engine, extension system. This is the pipeline.
Well, thank you so much, Stefan. I think we have covered almost all the questions. I don't see any more questions left. Cool. I think we can call it a day. Mike, Stefan, Mika, any closing lines before we close the session?
Thank you everyone for joining us. And if you want to have any further discussions, please get in touch with us. We'd love to chat a little bit more.
Just make sure to download the new version if you are not customer yet, and do a trial of it. And if you are a customer, then there's a free version of the product available for everyone. There's one policy that you could build. It's already very powerful. And if you will be interested, then reach out to our team or to me directly. I love chatting about this product. We've been working on it for a few months now, and are very excited to hear your feedback.
Yeah, thanks for all these interesting questions. Thank you.
Thanks, Mike, Mika, and Stefan. And thank you to all the attendees who joined us today. So we will be sharing the recording as well as the presentation in a follow-up email. And we have a resource section in the presentation where we will be sharing links to all the useful resources, including how you could actually get access to Data Hub. And feel free to reach out to us if you have any follow-up questions. We are here, and contact details of Stefan and Mika and Mike are in the presentation. You will have access to them. So thank you so much. Take care. Bye-bye.
Thank you.
Bye.